We're 3D Chimera, and this is our team presentation for the TDP Challenge. We'd like to start right off with the good stuff here. This is our final submission piece for the TDP Challenge. This part was printed out of a glass fiber reinforced nylon. It's printed with 6 shells on it in 0.2 millimeter layers. I'd like to highlight our innovation for you a little bit here. On this part, you'll see that our hooks are actually printed as a separate piece. So we went with a dovetail design here on the hooks themselves so that it can be printed in a flat orientation. By printing in that orientation, we're able to get 5 times the strength on the part that we could get if we were printing it in a vertical orientation. Now, of course, in our final submission, that part will be bonded in. We're going to be using a 2-part epoxy to do that. But for our video here, we wanted you guys to see how it works. So I'm going to tell you a little bit about the machine that we used for the challenge. So this is our German RepRap X400 3D printer. This is a FDM style 3D printer, dual extruders with a heated build plate. It's an open material platform. And what's really nice about it is this machine is designed and built in Munich, Germany. They're super robust mechanical systems, which are very, very reliable. What that allows us to do is really focus in on the print parameters in order to tune the settings for a particular material or application. And that's exactly what we did here. So you can see the part that's in the machine there. That's actually our challenge piece, just printing an extra copy there. We've got a custom setup on the machine. This is a 3D Chimera dry box up here to keep the filament dry. We've got hardened drive wheels and a hardened nozzle there on the system as well. And that allows us to get good reliability out of it and a lot of prints continuously out of the system. So the material itself comes from DuPont. This is what it looks like here, kind of in its unprinted state. You can see a few examples of things that we've printed in the past here with this material. One of my favorites is this skateboard here. This is actually designed to support me. So for any of you guys who've ever met me before, I'm a pretty giant dude, 6'4", and this is plenty strong enough for me to ride around on the street with. All the parts there are printed in the glass fiber reinforced nylon from DuPont. We've also got some test fixtures and a few other things that we've printed on these systems. Now, when we're looking at a challenge like this, it's really critical for us to think about what types of parameters we can adjust in the printer in order to get a different effect. So we looked at things like the layer thickness, extrusion multiplier, the extrusion temperature. We even looked at there's a brother material, if you will, carbon fiber reinforced nylon. We checked that out as compared to the glass fiber. We actually found the glass fiber was way stronger, which was a little bit of a surprise. We played with all these different parameters in order to get an optimum setting. So I'm going to walk you into the back of the shop here so that you can actually see some of the test results. And here's Julian. He'll be able to tell us a little bit about the procedures that we went through.
Thanks, Alex. So reading through the TDP report, we learned pretty early that we needed to build and replicate these test fixtures for the strength tests and the pressure tests. And so we identified that we could cut slice sections out of the part and rapidly iterate different test parameters. Let's say we wanted to test the extrusion multiplier, the temperature, the layer height. We had a method there that we could rapidly test. And one of the first things that we did actually was just print the part straight up in the standard orientation. Like, imagine this being the build plate. We printed that up and all the layers are in kind of this direction. And so in our test fixtures, we found with just one hook printed in the standard orientation that one, it broke on a layer line as expected. Also, it only held about 80 pounds per hook. So 2 hooks being 160 pounds, we knew we wouldn't pass the 200-pound threshold. And so we kind of played around with a few settings, and after a late night, we decided to test one of our standard sample parts that we give out to customers for this glass fiber nylon, because previously we had towed a 3,000-pound vehicle from a start, and it held up okay. We didn't know what that maximum load was, so we were curious. And one key thing to know is that we print these horizontal. So the part here, it held up about 400 pounds. So now compared to our vertical test, 80 pounds versus 400 pounds, we thought that was a no-brainer. We had to find out some way to incorporate this layer orientation into the final part. There were a couple things that we were thinking of, glue being one of the main constituents of the part. So we decided to take literally just a digital section off of the part. We cut that in SolidWorks, and just worst case scenario, two-part epoxy them together in a lap joint. And we found that the part actually broke before the glue did. So we were highly confident that this was going to be our solution. And so kind of iterating upon this slicing and gluing approach, we wanted to build in a mechanical interlock. And that's where we came to the conclusion of our dovetail piece. We iterated a couple just for fit and finish, and that allowed us to come to our final part here that we will glue for our final submission.
So we actually do have a part that's all glued up. It's hanging in the back here on our strength test fixture. And we thought this would be a great opportunity for us to show you the actual strength of the part and see what it can do. So we've got our system loaded up here. We've got about 19 cinder blocks on there. And you ready, Julian? Let's do it. Let's see how it goes.
All right. Looks like we're airborne here.
All right, let's see what we're at in terms of a load. So we're looking at about 610.6 pounds there. You can see our dovetail joint is holding up just fine there. And the parts have turned out pretty great. We were thinking about putting on more weight, but we're out of cinder blocks. So we're very happy with the results, and we hope that you guys are too. We can't wait to see what the other teams come up with, and we look forward to the competition wrapping up here in a couple weeks.